All right, section 6 of chapter 4 deals with some other types of transformations of functions. But first, we will look at the absolute value function. Okay, with the absolute value function, looking at it by making a table of values first, and selecting some values for x, starting with 0. If you substitute a 0 in, you would have the absolute value of 0, which is 0. Putting the coin 0, 0 is right here. Then substituting a 1 in, you would get 1. A 2 would get you 2. A 3 would be 3. And so on and so forth on the positive side. Then if you look at the negative side and you substitute a negative 1 in, the absolute value of a negative 1 is 1. The absolute value of a negative 2 is 2. And the absolute value of a negative 3 is 3. And so on and so forth. So you would have these coordinates. And so in drawing the graph of this, you would have a V. This V has a vertex at 0, 0. The slope of this line here on the right side of the V would be 1, and the slope on the left side would be a negative 1. Now, if we look at some other functions, this one here is function f of x equals the absolute value of x plus 2 minus 3. And knowing what we know about what happens to things when it's here and there, you should recall that this function would be shifted left 2 places and down 3. Left because when it's with x it's always the opposite, and when it's outside of it then it's the same. So we know then that our vertex is going to be left 2 and down 3. So our vertex is going to be at a negative 2, negative 3. And then from there, our slope would be up 1 and over 1 and up 1 and over 1. And it would still be a V. Then from yesterday, dealing with the square root function, you learned that when you have something like f of x equals a negative absolute value of x, because that negative is outside of the absolute value, it is going to flip it over the x-axis. So now, because it is the absolute value of negative x, we still would have a vertex at 0, 0, but now this side would flip over the x-axis, so instead of having a slope of 1, it would become a negative 1. And would run like so. And this side usually has a negative 1 for a slope, but now because it is going to be flipped over the x-axis, the slope of it is a positive 1. Because you're actually moving in this direction. Because you always move from left to right, but it stops right here. So when you draw it, it's easier to go from the starting point, or the vertex. And so it's just an upside down V. And many other things can happen to our absolute value function. And what they're dealing with today will be things like this, where it's 2 times the absolute value of x. Now those are going to affect the y values because it's not inside with the x. And so if we're going to look at this with a chart, if you pick the coordinate 0, substituting 0 into this would still be 0 times 2 is still 0. So it's still going to have a vertex at 0, 0. Now when you substitute a 1 in, absolute value of 1 is 1 times 2 is 2. If you substitute a 2 in, 2 times 2 is 4. And so we'd have 1, 2, 2, 4. 3 would be 6, 4 would be 8, and 5 would be 10. And so now this side of our absolute value has a slope of 2. Looking at the other side, at a negative 1, absolute value of negative 1 is 1 times 2 is 2. Negative 2 is going to be 4, negative 3 is 6, and so on and so forth. So on this side, we are going to have those coordinates, which connect and makes the slope of this side a negative 2. So this will change the slope of both sides of the absolute value. And then finally, if we have something like f of x equals 1/2 of the absolute value of x minus 2, we put both things together. The minus 2 is going to shift it to the right 2, and the 1/2 is going to multiply or change our slope to a half. So we would be, our vertex, instead of being at 0, 0, would now be over here at 2, 0. And now because this slope is a half, we would go up 1 and over 2. And our slope would be here. And on this side, same thing, up 1 and to the left 2. And this slope would be a negative 1/2. Okay, one other example would be if we have f of x equals a negative 2 times the absolute value of x plus 1 minus 3. And we'll change this and use red, since we've already used green as our original absolute value function. And so now the plus 1 will shift it to the left 2, or left 1. The negative 3 will move it down 3. And so our vertex will be left 1, down 3. So at a negative 1, 3. And now because our multiplying value out front is a negative 2, that is going to flip our graph over the axis. Well, now it's over the vertex. And so on this side, it will be down 2 and over 1. And on this side, it will be down 2 and to the right, or left 1. And that is how the graph of this function would look. And that is pretty much everything from section 4.6. So for your pleasure today, you get to do page 214. 1 through 6, 8, 10, and 11. Hope you enjoy.